Here we have a 10-foot ladder resting against a wall. The base of the ladder is 5 feet from the wall, and the bottom of the ladder is being pushed towards the wall at a certain rate, half a foot per second. The question is, and the rate we want to find, how fast is the top of the ladder moving after 8 seconds? In these related rate questions, they have to give you a rate, ask you for a rate, and tell you when. Often a good thing to do is draw a picture. So I'll do my best. We have a ladder leaning up against a wall. So here's my ladder. Now we know that this ladder is 10 feet and the base of the ladder is 5 feet from the wall. Now I should also label this with variables. It would be a natural thing to call the horizontal direction x, the vertical direction y, and if we have to, I'll call this hypotenuse z. If you notice, this makes a right triangle. We also have the base of this ladder moving towards the wall. That means the ladder is changing in the x direction. I'll label that as x prime as minus 0.5 feet per second. That's because in my picture, the base of the ladder is moving to the left, which is the negative x direction. Now, what rate are we asked for? We're asked for how fast is the top of the ladder moving. In other words, what's the y derivative? How fast is the ladder moving in the y direction after 8 seconds? We have a picture and it's labeled, we need an equation relating everything. And we have a right triangle with 3 sides. You should think Pythagorean theorem. Here, x squared plus y squared equals z squared, the hypotenuse. One thing that's nice is that the length of the ladder, 10 feet, is fixed. That's not going to change, so we can automatically fill in z equals 10 or that z squared equals 100. If you like, now that we have our equation, we can implicitly differentiate both sides with respect to time and plug in what we know to solve for what we want. Let's go ahead and do that. The derivative of x squared, that's 2x, but it's implicit differentiation with respect to t, so I need to multiply by x prime. You also might use the notation dx over dt. Same thing with y. The derivative using the power rule of y squared is 2y, but I need to multiply by y prime for the same reason. The derivative of a constant is 0. Now y prime is what we're trying to solve for, so we have to fill in everything else. If you like, you could take a second and just cancel the 2's, divide both sides by 2. X prime was given. X prime was given as minus 0.5. Y prime is what we're solving for, and we actually don't know what x and y are in this equation. The only piece of information we didn't use is that we're checking after 8 seconds. So if the wall is moving at minus half a foot each second after 8 seconds, well, x was initially 5, but we have to subtract half a foot for 8 seconds. In other words, 5 minus 4 is 1. So the x value here is just 1. And at that very moment in time, if we know what x is and z is always fixed at 10, we can find y just by going back to our Pythagorean theorem and plugging in x equals 1. So really we have 1 squared plus y squared equals 100 at 8 seconds. 1 plus y squared equals 100. Y squared equals 99. We can just plug in for y as the square root of 99. I'm going to ignore the plus and minus square root. It doesn't make sense to have a negative length in this case. Hey, we have all the numbers. Let's go ahead and just solve for y prime. I'll just add 1 times 0.5 to both sides. That would be root 99 y prime equals 0.5. And if we divide both sides, we're getting that y prime is 1/2 divided by root 99. You could also say 1 over 2 root 99. Your final answer should include the units. This ladder was moving in feet per second, and we've solved this related rate.